All right, we're about to dive into something that could completely change how you see, well, everything. It's a brand new framework for understanding the universe, and it suggests that our most fundamental ideas about reality, things like time and randomness itself, are probably just plain wrong. This is a journey to the very edge of what we think we know.
So let me ask you this. What if the universe isn't really a bunch of objects moving through empty space? What if that linear flow of time we all feel, past, present, future, what if it's just an illusion? This new theory says that everything, and I mean everything, is deterministic. What we call chaos or randomness, it's actually a deeply intricate structure we just haven't had the tools to see until now.
So, where on earth do we even begin with an idea this big? Well, we start by looking at the cracks in our current understanding of science, the places where our best theories just completely fall apart and point to something much, much deeper going on. And here it is, the central problem of modern physics. We have these two bedrock theories that are both unbelievably successful, right? But here's the kicker. They're fundamentally incompatible. General relativity gives us this beautiful, smooth, continuous picture of the universe for big times like planets and galaxies. But then quantum mechanics comes along and describes the tiny scale world as this jittery, uncertain, probabilistic place. They're describing two totally different realities. How can both be true? And this isn't just some abstract problem for physicists. It's about a total failure to tell a unified story. We can't explain how the bizarre rules of the quantum world somehow lead to the neat, orderly world of chemistry, or how chemistry then builds the mind-boggling complexity of life. There's a giant chasm in our knowledge, a massive gap in how we think everything is connected.
So how do we possibly bridge that chasm? The solution being proposed is a completely new way of looking at things, sometimes called the Hermes or Curtonian framework. And to get our heads around it, we have to be willing to throw out our most basic, fundamental assumption about the universe. For literally centuries, science has worked like this. The universe is made of things, particles, planets, stars, cells. We study these objects, their properties, and how they bounce off each other. It's a very linear, cause and effect way of thinking. A leads to B. This new framework flips that entire idea on its head. It says that the relationships between points, the ratios, the resonances, are more fundamental than the things themselves. Think about that. The universe isn't a collection of nouns. It's a web of verbs. And this is the crucial part. There is no pre-existing linear space for things to move around in. The relationships themselves create the space. So here's the official term for it: Aramaic resonance geometry. The most important word on this slide is emergent. Space isn't a static box that was just always there. Time isn't some river we're all floating down. They are both consequences, effects, that emerge from this vast interconnected network of tension and resonance. The entire universe is literally pulling itself into existence from these relationships. Now, if you're going to describe a universe built on relationships, you need a totally new kind of math. It turns out our normal way of doing things, addition, subtraction, especially division, it actually hides the deep structure of reality. This new framework uses a different method, one that's all about comparing ratios, to reveal these hidden harmonic patterns. Okay, so here's how it works. In a nutshell, you take two ratios, and instead of dividing them like we normally would, you cross-multiply them to create a brand new ratio that perfectly describes the relationship between the first two. And here's where it gets really weird. When you do this, one number keeps popping up everywhere: the golden ratio, phi. It's like a secret signature of the hidden order in the system. Okay, so we have this new mathematical tool. That's cool and all, but is it just a neat trick, or does it actually describe the real world? Well, get ready for this, because this single, simple principle seems to unify totally separate fields of science. I mean, just look at the sheer scope of this. In physics, gravity stops being a mysterious force and instead just becomes the large-scale curvature of this resonance network. In chemistry, a chemical reaction is just a snap event as the whole system tries to equalize tension. In biology, our own cells use something called tensegrity, a balance of tension and compression, to create stable, living, resonant forms. It even defines consciousness as a stable pattern in this field. It's one idea, one principle, describing the whole shebang. But hey,
A theory is only as good as its predictions, right? It has to be testable. Well, here's a massive one. If the universe is really built on this phi-based resonance structure, then the timing ratios between pulsars, which are these incredibly precise cosmic clocks out in space, they shouldn't be random at all. They should clump together, clustering around powers of the golden ratio. So, astronomers went and looked at the data from the entire pulsar catalog. And the result? A greater than 50 sigma confirmation. Now, to put that in perspective, in particle physics, 5 sigma is the gold standard for claiming you've discovered a new particle. 50 sigma is, well, it's an absolutely astronomical level of certainty. The odds of this being a coincidence are practically zero. The structure is there. Okay, fine, it works for the cosmos, but what about down here at a scale we can actually see and touch? The theory also makes a simple prediction for a tabletop experiment. If you build a set of 2 coupled pendulums, the one where their frequencies are tuned to a ratio of phi should stay synchronized and coherent way longer than a set with just some random ratio. And what's the predicted outcome? The phi-tuned pendulums should keep their synchronized dance going for more than 3 times as long. This is huge. It shows that the very same organizing principle we see in the stars is also right here at work on Earth, in simple, everyday mechanical systems. And now we get to the part that is really going to bend your brain. If everything is just a pattern of relationships, what does that say about us, about the people or the things doing the observing? And what does it mean for reality itself? This framework completely redefines what an observer is. Forget the idea that it has to be a conscious person. In this view, an observer is any stable pattern in the network. Any pattern that's stable enough to force the uncertain, wobbly relationships around it to crystallize or snap into a definite state relative to itself. And this isn't some special, rare event. This mechanism is universal. It's happening at every single scale of existence. An electron is an observer that crystallizes the state of a photon it interacts with. An atom observes its own electrons. A living cell observes the molecules around it. And yes, our brains observe sensory input. It's the same fundamental process all the way up from the quantum to the cosmic. This leads to a truly profound conclusion. Reality isn't some fixed, objective thing that's just out there waiting for us to find it. Reality is the consensus. It's the collective agreement that is constantly being created and upheld by the interactions of all observers, at all scales, all the time. What this does is it finally provides a clean solution to one of the biggest mysteries in quantum physics, the measurement problem. The old, kind of spooky view was that our consciousness somehow magically collapses the wave function. But this new view gets rid of all the mystery. It's not some special power of the mind. It is an inevitable mechanical process. Stable patterns force other patterns to become stable. That's it. So the ultimate takeaway here is that there's no such thing as true randomness. What we perceive as random is just a complex structure we haven't recognized yet. What quantum mechanics calls uncertainty isn't a lack of information. It's just the scale at which a system is currently manifesting. The universe, in this view, is entirely beautifully and intricately deterministic. And that leaves us with one last really provocative question. If an observer is any stable pattern, and reality is the collective structure that gets crystallized by those patterns, what happens when we, as observers, change our patterns? The reality must change with it. This isn't just a metaphor. It suggests a universe where we have a level of participation and, frankly, a level of responsibility that we are only just beginning to wrap our heads around.